Welcome to EPG Pathshala. I am Mrs. P.G. Batmagauri, working as an Assistant Professor in Faculty of Engineering, Avinash Lingam University, Coimbatore. Today we are going to discuss about factors influencing requirements of light. Lighting is an essential part of any buildings. Apart from its aesthetic and decorative aspects, good lighting has a strictly utilitarian value in reducing accidents, increasing the output of the factory and other workers, and improving the general health of the community due to the reduction of eye strain. The science of illuminating engineering is therefore becoming a major importance. Objectives: to understand the nature of light, explanation, impart about various artificial lighting sources, design of lighting system, placement of effective lighting system for buildings. Natural lighting. We got solar lighting during daytime, also called as natural lighting, to get sunlight through windows, doors, ventilators, etc. will be placed in proper size and place. Insufficient sunlight in building and nighttime illumination taken care by proper electrical lighting system. It is called artificial lighting. In this, we discussed about elements of light and factors influencing the requirements of light. Artificial lighting. Artificial lighting is playing an increasingly important in modern everyday life. Wherever an electricity supply is available, electrical lighting are used. Because electricity produced light on account of its cleanness and ease of control, as well as low cost, possesses many advantages over alternative lighting sources. Nature of light. For proper appreciation of modern developments in lighting, to study the nature of light and the fundamentals principle are essential. Either ways, certain of these, namely those having wavelengths of between 0.4 meter and 0.75 meter, produced when they impinge on the eyes the sensation known as light. All these waves travel at the speed of 3 into 10 to the power of 8 meter per second. Another common unit is angstrom unit, which is equal to 10 to the power of minus 8 centimeter or 10 to the power of minus 10 meter. Color of light. Different wavelengths within the above visible spectrum give the light of different colors. Frequency 480 to 405, wavelength interval 725 to 740 nanometer, it gives red color. Similarly, the frequency 580 to 530 terahertz, the wavelength interval is 520 to 565 nanometer, it gives the green color. Before any quantitative investigation concerning lighting can be carried out, it is necessary to have units in which it can be measured. The most important qualities which have been specified being luminance intensity of the light source, the total quality of the light emitted by the source, and the illumination on the given surface. Luminous intensity. A source of light is specified by comparing it with a standard lamp. The unit of luminous intensity is called candle power or candela. An ordinary 60 watts lamp has used for domestic lighting, when viewed from the floor, have a luminous intensity of about 70 candle power, while a torchlight viewed from along the beam may have luminous intensity, while a searchlight viewed from along the beam may have the luminous intensity of as much as million candle power. Brightness. When the source of light covers an appreciable area, as when it is contained in an opal glass bowl, or when the observer sees only the reflected light, as in the cinema screen, the term brightness is employed. This being defined as the luminous intensity per unit area and expressed in candle power meter square. Quantity of light lumen. The total quantity of light or luminous flux from a source is expressed in lumens. The lumen being defined by stating that the amount of light emitted from a source having a luminous intensity of 1 candle power in all directions is 5 pi lumens. An ordinary 60 watt input of lamp will have an output of about 700 lumens. Illumination. Illumination on a surface is governed by the total amount of light or lumens flux falling on that surface, and it is therefore measured conveniently in lumens per square meter. Another name for lumens per square meter is lux. Luminous efficiency and sensitivity of the human eye. As human beings are concerned, the existence of the light becomes apparent only as a result of the radiant energy of the wavelength of between 7000 wavelengths of between 4000 and 7500 AU falling upon the eye, which in turn transmit sensation to the brain. Design of the lighting system. Design of the light system classified into direct lighting, indirect lighting, semi-direct lighting, semi-indirect lighting. Direct lighting. Direct lighting is one of the most commonly used lighting system. In this, more than 90% of total light flux is made to fall on the working plane with the help of deep reflectors. It causes shadows and glare used for industrial and general outdoor lighting. Semi-direct lighting. In this scheme, 60 to 90% of total flux is made to fall downwards directly using semi-direct reflectors, while remaining light flux is used to illuminate ceiling and walls. This scheme is suitable for rooms with high ceilings. Semi-indirect lighting. In this scheme, 60 to 90% of the total light flux is thrown upwards to the ceiling and the rest reaches the working plane. This scheme is with soft shadows and glare free. It is used for indoor light and decoration purpose. Indirect lighting. In this scheme, more than 90% of total light flux thrown upwards to the ceiling by using inverted or bowed reflectors. Here, glare was minimum. It is used for decoration purpose in the cinema theatres and hotels. Requirement of good lighting. A good lighting is one under the influence of which the eyes of person using the light do not have any strain. Example, if the light is too dim, serve the objects properly or cannot do reading or writing work. On the other hand, if the light is too bright, our eyes start watering and are made so open forcibly. The good lighting should be comfortable while working under it. Perfect lighting system. The perfect lighting system should have to provide sufficient illumination, provide uniform light distribution all over the working plane, provide light of suitable color, avoid glare and shadows. The following factors are to be considered while designing the lighting scheme. Illumination level. For each type of work, there is a range of brightness which gives maximum output in terms of quality and quantity. The degrees of illumination to give necessary brightness of the objects depends on the size of the object to be seen, the distance between the object and the observer, contrast between the object and the background, time duration to which the objects were seen. Moving objects requires more illumination. The illumination level required in various parts of the building are shown in the following table. For example, for residential house, the living room, bedroom, kitchen and bathroom needs 90 lux luminance intensity. For sports, indoor sports, it requires 500 lux. Educational institutions, library, it needs 120 lux. Uniformity of illumination. The human eyes adjust itself automatically to the brightness within the field of vision. If there is a lack of uniformity, the human eye has to adjust more frequently and thus fatigue is caused, human eye and productivity is reduced. Nowadays, local lighting plus general lighting is adopted, especially in mass production factories, offices, drawing offices, shops, etc. Color of light. The appearance of the body color entirely depends on the color of the incident light. The composition of the light should be in such that objects appears naturally. Daylight, LED tubes nowadays make it possible to illumination economically even large spaces with artificial daylight giving good color rendering. Glare and shadows. Formation of shadows causes fatigue for eyes. Shadow can be avoided by using large number of small illuminarities, by using white surface sources of light, by using indirect lighting system. Direct glare from the source of light is more often a hindrance to vision. Glare can be avoided by mounting a light source at the height above the ordinary range of vision. Types of lamps: arc lamps, high temperature lamps, gaseous discharge lamps, fluorescent lamp, CFL lamp, LED lamp. Arc lamps. Electric charge discharged through an air gives intense light. The arc is when an electric current is made to flow two electrodes 2 to 3 mm apart. The arc maintains the current and is very efficient source of light. Different types of arc lamps are carbon arc lamps, flame arc lamps, magnetic arc lamps. Incandescent lamp. When an electric current is passed through a fine metallic wire, heat is produced and the temperature of the wire increases. At low temperature, the wire radiates heat energy. As the temperature of the wire increases, the radiates heat as well as light energy. The higher temperature of the wire, higher the amount of light energy radiated. The incandescent or filament lamp consists of glass globe completely evacuated and a fine wire known as filament within it. The glass globe is evacuated to prevent the oxidation and also to prevent the high temperature being lowered by radiation. The metal is used for filaments. Most have the properties of high melting point, low vapor pressure, high resistivity, low temperature coefficient and sufficient mechanical strength to withstand vibration during use. Carbon, osmium and tungsten can be used as a filament materials. The types of incandescent lamps are gas-filled lamps, halogen lamps. Advantages of incandescent lamps: direct operation on standard distribution of voltages, operating power factor unity, availability in various shapes and shades, good radiation characteristics in the luminance range, no effect on surrounding air temperature. Applications of incandescent lamps are: it is used commonly lighting system in home, hotels and closed environment. Halogen lamps are used in outdoor illumination of building, playground, large gardens, car parking and airport runways. Gaseous discharge lamps. Gases are normally poor conductors at atmospheric and higher pressure. Within the application of suitable voltage called as ignition voltage across the two electrodes, there will be a discharge through the gas accompanied by electromagnetic radiation. The wavelength of its radiation depends on the gas, its pressure and the metal vapor in lamp. Argon gas, sodium and mercury vapor gas are commonly used in gaseous discharge lamps. When the ionization has started in gas, it has tendency to increase continuously, resulting in fall of circuit resistance. This is called as negative resistance characteristics. Choke or ballast is used to limit the current to safe value. To improve power factor, instead of choke, condenser is used. Advantages of gaseous discharge lamps used in outdoor applications: lumens efficiency 30 to 65 lumens per watt, long bulb life 24,000 hours. Lamps are typically not used retail stores, schools, hospitals and other similar commercial applications. Limitations: because of use of mercury, the deposital of lamps are not easy. These lamps are typically not used in retail stores, schools, hospitals and other similar commercial applications. Fluorescent type lamp. A fluorescent lamp or fluorescent tube is a low pressure mercury vapor gas discharge lamp that uses fluorescence to produce visible light. An electric current in the gas excites mercury vapor, which produces short wave ultraviolet light that then causes a phosphor coating on inside of the lamp to glow. A fluorescent lamp converts electrical energy into useful light much more efficiently than incandescent lamps. The typical lumens efficiency of fluorescent lighting system is 50 to 100 lumens per watt. Several times the efficiency of incandescent lamp with comparable light output. Because they contain mercury, many fluorescent lamps are classified as hazardous waste. As when the other type of lamps of discharge lamps, a choke is used in series with the capacitor is connected. At starting, a switch short circuit the lamp and allows the current flow through the electrodes, and the choke is in series. After about few seconds, the switch automatically open, causing a voltage surge large enough to strike the arc between the electrodes. The arc being then maintained by the normal lamp voltages. Bombardment of the electrode surfaces by positive mercury ions maintain their temperature so that they continue to emit electrons. Because of mercury filled inside, a glow discharge takes place. Advantages of fluorescent lamp: energy efficient, best use of interior lighting, manufacturing cost is low, long life of tube, good selection of desired color, temperature. Limitation of fluorescent lamp: the flickering can be present, power factor is very low, poorly designed ballast can create fires when they overheat. CFL lamp. Fluorescent light and CFL are very similar, but it is a compact version of fluorescent lamp that is easier to install. The glass tube is bent and both ends are fixed onto the base that holds in a ballast and can fix into the ordinary incandescent bulb socket. A compact fluorescent light is an energy saving light. The compact fluorescent tube was replaced by incandescent light with the same socket. The service life also higher than incandescent light. Advantages of CFL lamps: CFL are up to 4 times more efficient than incandescent bulbs. CFL are used third of the electricity and last up to 10 times as long as the incandescent bulb. Just one bulb can reduce a half ton of carbon dioxide from the atmosphere over the life of the bulb. Limitations: while CFL are supposed to last about 10,000 hours, turning them on and off too frequently can reduce the lifetime of the lamp. They are also sensitive to temperature, and low temperature can be caused lower light levels. The most alarming, thinning the environmentally conscious consumers, is the presence of mercury in CFL. Mercury is toxic metal, and while it does not pose any danger when the bulb is being used. LED lamps. An LED is abbreviated as light emitting diode. It is basically a small light producing semiconductor device capable of emitting visible light. When it is that comes under active semiconductor electronic components. LED lamps have a long lifespan and electrical efficiency which is several times higher than incandescent lamp. The initial cost of LED is usually higher. Degradation of LED dye and packaging materials reduces light output to some extent over time. Like incandescent lamp and unlike most fluorescent lamp, LEDs come to the full brightness without need a warm-up time. The life of fluorescent lighting is also reduced by frequent switching on and off. Most LED do not emit in all directions. The light output of single LED is less than that incandescent and compact fluorescent lamps. In most applications, multiple LEDs are used to form a single lamp. The LED chips operated with direct current. Appropriate driver circuit is required to operate the chips in alternating current. LEDs are easily affected by high temperature, so lamps typically include heat dissipation elements such as heat sinks and cooling fans for high power LED lights. A good LED driver can guarantee a long life for LED system and provide additional features such as dimming and control. The LED drivers can be put inside the lamp or luminary, which is called as built-in type, or put outside, which is called as independent type. According to the different applications, different types of LED drivers need to be applied. For example, an outdoor driver for street light, an indoor drive for the down light, etc. Advantages of LED light: energy efficiency compared with other CFL fluorescent lamp. for same lumens, 50% of power is consumed by LED lights. Long life quality, LEDs have an expected lifespan of 30,000 to 50,000 hours or even longer. Operated in cold storage places. Durability of LED are very high durable. LEDs are breakage resistant and largely immune to the vibrations and other impacts. LEDs emit virtually no infrared radiation or ultraviolet radiation. Energy efficiency of lamp. Over years of development, the lamp technology has led to the improvements in efficiency of lamp. High efficiency LED lamps can be used in place of incandescent tube. Energy used by the lamps is given by watt is equal to the unit of measurement of energy. 1 watt is equal to 1 amperes into 1 volts. Comparison of various voltage in terms of watts, it is given in the table. With the comparison, LED lamps consumes less the energy and provide more brightness, that is lumens. The end of the session, the nature of light was elaborated. Many artificial electrical lighting sources and its working was discussed. To increase the lighting quality in a building, placement and selection of proper lights is very important. Using simple changes in lighting systems in buildings, we enhance quality of lighting and reduce cost of the electricity bill. Some recommendation of lightings are use of energy efficient fluorescent in place of conventional fluorescent lamps. Use of compact fluorescent lamps, that is CFL, in place of incandescent lamps. Use of metal handle lamps in place of mercury sodium vapor lamps. Use of high pressure sodium vapor for applications where color rendering is not critical. Use daylights in place of filament lamps. Optimum use of day lighting. Use of high frequency electronic ballast in place of conventional choke.